Good morning, students. In this class, we will discuss about Unit 4 multiple integrals. The topic is double integrals evaluation. Double integrals, evaluation of double integrals. Contents, objective and outcome, introduction, evaluation of double integrals, working rule, and applications. Objective and outcome. The objective is evaluation of double integrals and outcome will be student get to understand the concept of evaluation of double integrals. Introduction. A double integral or triple integral is an extension of a definite integral of function of a single variable to a function of two or three variables. So here the double integration topic is an extension of definite integral which is already known of function of single variable. But here in this double or triple integrals, we will discuss about two or more variables. Two variables for double integrals and three variables for triple integrals. These are useful in evaluating area, volume, mass, centroid, and moments of inertia on plane and solid regions. Working rule. When x1, x2 are functions of y and y1, y2 are constants, f of xy is first integrated with respect to x, keeping y fixed. That is, y is treated as constant within the limits of x1 and x2. Then the resulting expression is integrated with respect to y between the limits y1, y2. That is, here the problem is a double integration. Here the limits are given as x limits are in terms of y and y limits are y1, y2. These are constants. Whenever the double integral limits are this type, then we have to apply integration first with respect to x and then y, because we have to give the preference for variable limits. First, the inner integral is resolved. That is, we have to integrate first with respect to x because x limits are in terms of y. That is, x limits are here variable limits. So that while integrating with respect to x, we have to keep y as fixed. First, we have to resolve the inner integral while integrating with respect to x. Y keep it as fixed as constant, and then we have to integrate with respect to y. Clearly y limits are constant. Now the result of the double integral must and should be constant, so that we have to apply the integration first with respect to x and then y. Don't forget, while integrating with respect to x, keep y as constant, and while integrating with respect to y in double integrals, keep x as constant. The order is with respect to x and y. While integrating with respect to one variable, treat other variable treated as constant. So here x1, x2 are functions of y and y1, y2 are constants. F of xy is integrated. F of xy is integrand function integrated with respect to x and keeping y as constant. That is, keep y is fixed within the limits x1 and x2. And then the resulting expression, the resulting means on resolving this inner integral, the resulting expression is integrated with respect to y between the limits y1 and y2. What are y1 and y2 here? Constants. Second step, when y1, y2 are functions of x, that is y limits are in terms of x, that is y limits are variable limits, and x1 x2 are constants, that is x limits are constants. F of xy is first integrated with respect to y and keep x fixed, that means x is treated as constant between the limits y1 and y2, and then the resulting expression is integrated with respect to x within the limits x1 and x2. That is, it is the double integration, it is inner integral, it is outer integral. First we have to resolve inner integral because y limits are in terms of x, that is y limits are variable limits. Always we have to give the preference for variable limits, so that we have to integrate here with respect to y and then x. So because y limits are variable limits in terms of x, while integrating with respect to y, keep x as a constant, that is x is fixed, and then the resulting expression is integrated with respect to x. But while integrating with respect to x, we have to keep y as constant. But the resulting expression is already in terms of x. Just we have to take the single integration under the limits x1 and x2. What are x1 and x2 here? x1 and x2 are constants. So once again, the double integration is evaluated as integrating first with respect to y and then x, because y limits are variable limits in terms of x. We have to give the preference for variable limits, and then we have to integrate with respect to x because the outer integral limits are constants. Step 3. When x1, x2, y1, y2 are all constants, that means all the double integral limits are constants. Here, integrating first with respect to y and then x, or integrating with respect to x and then y, because the order of an integration is immaterial. In case of all the limits of double integral are constant, then the order of integration is immaterial, provided the limits are to be changed accordingly, and we can apply the integration first with respect to y and then x, or first with respect to x and then y. Any order can be taken first, but the result cannot be changed. So in case of all the limits of double integral are constants, then apply integration first with respect to y and then x, or first apply integration with respect to x and then y. In both cases, we will get same result. In case of all limits are constants, here the limits of double integral are x1, x2, y1, y2. These all limits are constants. Apply integration with respect to y and then x, or integration applied with respect to x and then y. These are the three steps we have to resolve the double integrals. To get the constant as a result, we have to take all these three steps. Once again, if the limits are x limits are in terms of y and y limits are constant, then apply integration with respect to x and then y. If the limits of y are variable limits in terms of x, then apply integration first with respect to y and then x. Here x limits are constants. If all the limits of the double integral are constants, then apply with respect to x and then y, or with respect to y and then x. In both cases, we'll get the same result. These three steps are very important to find the result of the double integration. If f of xy equal to 1 in double integral, then the double integration is represented as area. So we can find area of double integral easily. The double integration integrand function. What is integrand function here? F of xy. If f of xy equal to 1, then the double integral gives the area over the region or problem. Evaluate integral 0 to 1, integral 1 to 2, x square plus y square dx dy. The problem is double integration sum because the two integrals are given, and all the limits of double integration is constants. So here we have to apply integration with respect to x and then y. If we want to integrate first with respect to y and then x, then the limits must and should be changed accordingly. Then only we get the result as constant. Same result we will get if we want to integrate the change the order. But here we have to apply the integration first with respect to x and then y, because all the limits are constants. 1 to 2 limits are related to inner integral with respect to x. 0 to 1 limits are according to outer integral with respect to y. Solution: given integral, we have to apply integration first with respect to x and then y. While integrating with respect to x in double integrals, we have to keep y as constant. X square integration is x cubed by 3, and y square integration, what is y square integration? Y square is a constant, just take it out the constant. One integration is x, so that is y square x. Limits of x are 1 to 2. So first we have to substitute upper limit to 2 and then lower limit 1. Formula is upper limit minus lower limit. We have to replace these limits upper and lower in place of x, because inner integral limits are related to x. So substituting upper limit, so we will get 2 cube by 3, that is 8 by 3, plus 2 into y square is 2y square, minus lower limit. What is lower limit here? 1. Substituting lower limit, we will get 1 cube by 3 is 1 by 3, plus 1 into y square is y square. Now simplifying, so we will get, so minus into 1 by 3 is a minus 1 by 3, and minus into y square is minus y square. But what is 8 by 3 minus 1 by 3? 7 by 3. And 2y square minus y square is y square. So now clearly the double integration is reduces as a single integration. Now we have to apply integration first with respect to y. So we have to apply the integration with respect to y. But 7 by 3 constant whose integration is 7 by 3 y, and y square integration is y cube by 3. Now we have to replace upper limit as 1 in place of y. So we'll get 7 by 3 into 1 is 7 by 3, plus 1 cube by 3 is 1 by 3, minus lower limit is 0. Substituting lower limit 0, 7 by 3 into 0 is 0, 0 cube by 3 is 0. That is 7 by 3 plus 1 by 3 is 8 by 3. So it is the required result of the double integration. So easily we can obtain the result of double integration. So once again, integrate first with respect to x and then y. While integrating with respect to x, kept y as constant, y is fixed, the term y is fixed, and then we have to apply integration with respect to x, substituting upper limit and then lower limit, upper limit minus lower limit. Simplifying the expression, clearly the double integration is reduces as single integration. Now applying the single integration with respect to y and then substituting upper limit minus lower limit, we will get the result as constant. So this is the procedure to evaluate the double integration whenever the limits are to be constants. Problem: evaluate integral 0 to 1 integral x to root x xy into x plus y dx dy. The given problem is related to double integration, and the inner integral limits are x to root x, that is y limits are in terms of x. These are the limits related to y, and the outer integral limits are 0 to 1. These limits are related to x. So here first we have to apply the integration with respect to y and then x. Solution: given integration. So here we have to change the order because y limits are here in terms of x. X to root x limits are related to y. so that we have to change the order, that is integration applied with respect to y, and then we have to apply the integration with respect to x. Don't forget, the y limits are must and should be in terms of x limits must and should be in terms of y, opposite terms. X limits must and should be in terms of y limits must and should be in terms of x. So here we have to apply integration with respect to y and then x. So while integrating with respect to y, we have to keep x as constant. So just multiply with xy. So we will have x square y plus xy into y is xy square. Now we have to apply integration with respect to y. We have to kept x as constant. X square is kept as constant. Y integration is y square by 2 plus x is fixed. Y square integration is y cube by 3. We have to replace upper limit as root x and lower limit as x. So these limits are replaced in place of y. So substituting in place of y as upper limit, that is root x whole square is x. Root x whole cube is root x means x power 1 by 2. X power 1 by 2 whole cube is x power 3 by 2. Upper limit minus lower limit. Now simplifying, we will get, simplifying means just multiplying the second term with minus. So and then simplifying, because these two are related to x power 4, just taking out x power 4, negative x power 4 common, 1 by 2 plus 1 by 3, that is 5 by 6, because 6 is the LCM of these two terms. Now the clearly double integration is reduces as a single integration. We have to resolve this single integration with respect to x. X cube by 3 integration is x power 4 by 4. Already we have 2, that is x power 4 by 8. 1 by 3 is constant. X power 5 by 2 integration is x power 5 by 2 plus 1 by 5 by 2 plus 1, that is 7 by 2. Minus 5 by 6 is constant. X power 4 integration is x power 5 by 5. Now upper limit is substituted and then lower limit is 0 substituted, and then simplifying, that means taking the LCM, we will get the result as constant, that is 3 upon 56. 3 by 56 is the result. So here don't forget, x to root x is limits related to y, and 0 to 1 limits related to x. So x to root x is related to y because y limits are in terms of x. Y limits are in terms of x. We have to apply integration first with respect to y and then x. Double integration is reduced as a single integration, and then single integration can be easily solved. So to get the result as constant, it is the it is the process to evaluate the double integral whenever one limit are variable limits, another limits are constant limits. Here we have to apply integration with respect to y and then x, because y limits are here in terms of x variable limits. We have to give the preference for variable limits and then constant limits. The outer integral limits are constant. Last we have to obtain the limits to be constants. That integration we have to apply, because we have to get the result as constant. Another problem, evaluate integral 0 to 4a integral y square by 4a to 2 root ay xy dx dy. Here y square by 4a to 2 root ay limits are related to x, and outer integral limits are related to y. So first we have to apply integration with respect to x and then y. Solution, given integral, first we have to apply integration with respect to x and then y. While integrating with respect to x, we have to keep the y as constant, y constant, x integration is x square by 2. Now we have to substitute upper limit as 2 root ay and then lower limit as y square by 4a. So substituting upper limit and lower limit in place of x, and then simplifying and then integrating with respect to y. 4a by 2 means 2a, y square integration y cube by 3. Minus 1 by 32a square is constant, y power 5 integration is y power 6 by 6. Now substituting upper limit as 4a and lower limit as 0 in place of y. So we will get, and then simplifying, so we will get 2 into 64 is 128, a into a cube is a power 4 by 3. Similarly, so we will have like this, and then simplifying, we will get the 3 as LCM, 120 a power 4, 128 a power 4 minus 64 a power 4 is 64 a power 4 by 3. So it is the required result of the double integration. Don't forget, x limits are variable limits in terms of y. These limits are related to x, and then we have to apply the integration with respect to y. We have to give the preference for variable limits. Another problem. Evaluate integral 0 to 2, integral 0 to x, e power x plus y dy dx. Here the integrand function is exponential function e power x plus y. Order is with respect to y and then x. Here the limits 0 to x are related to y. Y limits are in terms of x, and the outer integral limits are 0 to 2. Here the limits of x are constant. The order is, first we have to apply with respect to y and then x. Solution. Given integral, while integrating with respect to y, we have to keep x as constant. E power x is a constant. E power y integration is as it is e power y. While applying with respect to y, first we have to resolve e power x plus y as e power x into e power y, because it look like a power m plus n is a power m into a power n. E power x plus y is e power x into e power y. E power x is constant, and then integration for e power y is e power y. Now substituting upper limit as x and then lower limit as 0, we will have e power y replaced with x, so that e power x minus e power 0, but e power 0 value is 1. Don't forget the exponential function e power y integration with respect to y is e power y. E power x integration with respect to x is e power x. So replacing, we will have e power x minus e power 0, but e power 0 value is 1. Now multiplying with e power x into e power x is e power 2x minus e power x into dx. Clearly, the double integration is reduces as single integration. Now we can apply the single integration solving. That is e power 2x integration is, what is e power 2x integration? It is look like e power ax, but e power ax integration is e power ax by a. E power 2x integration is e power 2x by 2, and then e power x integration with respect to x is e power x. Now we have to replace upper limit as 2 and the lower limit as 0. That is e power 4 by 2 minus e square, substituting upper limit as 2, and then substituting lower limit as 0, e power 0 is 1, 1 by 2 minus 1. Now simplifying, we will get e power 4 by 2 minus e square. Half minus 1 is negative half. Already we have minus. Minus into minus is plus. Plus half. It is the required result. So simple. Integrand function is exponential function here. The limits of inner integral are in terms of x. These are the limits related to y, and then we have to apply the integration with respect to x. So first we have to apply integration with respect to y. Don't forget, e power y integration with respect to y is e power y, substituting upper limit and then lower limit, and then simplifying, double integration is reduces as a single integration. E power 2x integration is e power 2x by 2. E power ax integration is e power ax by a. So and then simplifying, substituting upper limit minus lower limit, the result is constant. Another problem. Evaluate integral 0 to 1, integral 0 to root of 1 plus x square, 1 by 1 plus x square plus y square dy dx. So order is here. Apply integration first with respect to y and then x. The problem is double integration sum because the two integrals are used here and the limits of inner integral are in terms of x. Here we have to apply integration first with respect to y and then x because y limits are variable limits in terms of x. Apply integration first with respect to y and then x. Solution: given integral, let it be I. Here we have to apply integration with respect to y and then x. But while integrating with respect to y, keep x as a silent, that is x is treated as constant. 1 plus x square is treated as constant. Now take 1 plus x square as some a square so that we will have a formula. So what is the formula here? Integral of 1 by a square plus y square dy is 1 by a tan inverse of y by a. Formula is 1 by a tan inverse of y by a. Now replacing upper limit as a root of 1 plus x square and the lower limit as 0 in place of y. So we will get tan inverse of root of 1 plus x square by root of 1 plus x square minus tan inverse of 0. So that is 1 by root of 1 plus x square. But what is the value of tan inverse 1? Pi by 4. Because 1 is replaced with tan pi by 4. Clearly tan get cancelled. So we will have pi by 4. But pi by 4 is a constant here. Just take it out, pi by 4. And then we will have integral of 1 by root of 1 plus x square dx. But what is the integration formula here? Log of x plus root of 1 plus x square or sin h inverse of x. So here we are using log of x plus root of 1 plus x square because logarithmic values are well known compared to inverse trigonometric functions. So that we are using here log of x plus root of 1 plus x square, or you can use sin h inverse of x also. So here we are using here log of x plus root of 1 plus x square. Now substituting upper limit as 1 and lower limit as 0. That is 1 plus root of 1 plus 1 square is root 2. That is log of 1 plus root 2. Substituting lower limit to 0, we will get log of 0 plus root of 1 plus 0 square is log 1. But log 1 value is 0. So it is the required result. So easily we can obtain the double integration result. Integration applied first with respect to y and then x. While integrating with respect to y, we have to keep x as constant. 1 plus x square is here taken as a square. It is look like 1 by a tan inverse of y by a. So answer is just replacing a with 1 plus root of 1 plus x square and then substituting lower upper limit as root of 1 plus x square and then lower limit as 0. But tan inverse 1 value is pi by 4. Pi by 4 is constant. Just take it out the constant. 1 by root of 1 plus x square formula, integration formula is log of x plus root of 1 plus x square. Substituting upper limit as 1 minus lower limit as 0. So we will get the result is constant. Now problem is evaluate integral 0 to 4, integral 2 sin theta to 4 sin theta or dr d theta. Here the problem is related to polar coordinates. Apply the integration with respect to r and then theta. But while integrating with respect to r, we have to keep theta as constant. But what is the r integration here? R square by 2. So don't forget r limits are in terms of theta because r limits are radii vector limits. R limits are in terms of theta and theta limits are constants. R integration is r square by 2. We have to replace these limits in place of r. Substituting 4 sin theta and 2 sin theta. So we'll get 4 sin theta whole square is 16 sin square theta by 2 minus 2 sin theta whole square is 4 sin square theta by 2. Upper limit minus lower limit into d theta. So 16 sin square theta by 2 minus 4 sin square theta by 2 is 6 sin square theta. So here 6 is constant. Just to take it out, the 6 as constant. Integration is applied to the sin square theta. but sine square theta can be written as 1 by 1 minus cos 2 theta by 2. 1 by 2 is constant, just take it out the constant, but 6 by 2 is 3. Integration is for 1 minus cos 2 theta. So 3 constant, 1 integration is a theta, cos 2 theta integration is a sin 2 theta by 2. Substituting upper limit as pi and lower limit as 0. Pi minus sin 2 pi by 2. But what is the value of sin 2 pi? 0. That is a 3 into pi is 3 pi. It is the required result. So easily we can obtain the result. Apply integration with respect to r and then theta, because r limits are variable limits in terms of theta and theta limits are constants. R integration is r square by 2. Substituting upper limit as a 4 sin theta and lower limit as 2 sin theta. So simplifying, clearly double integration sum is now reduces as a single integration. Sin square theta is replaced with 1 minus cos 2 theta by 2. 1 by 2 is constant, just take it out. 1 integration is a theta, cos 2 theta integration is a sin 2 theta by 2, because cos a theta integration is sin a theta by a. Sin a theta integration is minus cos a theta by a. Don't forget the formulas about single integration. Substituting upper limit and lower limit as 0. Sin 0, sin pi, sin 2 pi, sin 3 pi, and so on. Sin n pi is 0. So sin 0, 0, sin 2 pi is also 0. Substituting upper limit and then lower limit, we will get the result as 3 pi is the required result as constant. For any queries or any doubts, please contact. Thank you.